Aloha. So in this problem, we're asked to calculate the force leaving a hypodermic needle, and we're told that the plunger part of the needle is experiencing a force of 3.2 newtons. And since this is in the plunger part, I'll label this FP. And the diameter of that plunger part is, we're told, 1.3 centimeters, which is 1.3 times 10 to the minus 2 meters. And in the needle, the diameter is a lot smaller. It's 0.20 millimeters. So 0.2 times 10 to the minus 3 meters. And in part A, we want to find the force leaving the needle, which is a little Fn. And to answer this, we can use Pascal's principle. This is a confined fluid. So we know that the pressure leaving the plunger area is the same as the pressure leaving the needle. So label that P plunger equals P needle. And we can write out the pressure as, pressure is always force per unit area. So we can rewrite this equation as force over area in the plunger is the force over area in the needle. And we can rearrange this as an equation for the force in the needle, which is what we're trying to calculate. So just multiplying both sides by the area of the needle. And this is like a cross-sectional area through this essentially a round tube. So we know that the area is the area of a circle. That's pi, and we are not given the radius, we are given the diameter. So the radius is the diameter over 2. So that's for the plunger area, or sorry, that's for, at the top we had, this is the diameter of the needle over 2 squared for the radius squared. And this bottom term, we have the diameter of the plunger over 2 squared. And you can see the factors of pi cancel out, as well as the 2 squared there. So we have this equation in terms of all the given variables to calculate what we want in part A, which is this force through the needle. We can just plug in numbers we're given. 3.2 newtons. And just making sure we're consistent with units here, converting things to meters instead of millimeters and centimeters. So you should get an answer of about 7.6 times 10 to the minus 4 newtons. Just reporting our answer in terms of 2 significant digits. And then in part B, we are asked what pressure we need, what gauge pressure we need in the plunger section if we had, or what force would we need if the gauge pressure in the plunger section was 75 millimeters of mercury. So in that case, we want to find FP such that this is the pressure, a different pressure coming through the plunger section. And we could just use the formula for pressure is the force over the cross-sectional area that it's applied to. So this is all for the plunger region. So we can just find this force. The area is the same because it's the same plunger part of the needle. So that's pi r squared for the area, which is the diameter that we're given over 2 times this pressure. So we can just plug in these numbers. And we just want to make sure we convert from millimeters of mercury to newtons per meter squared. So we can just look up this conversion. So for 1 millimeter of mercury, we have 133 newtons per meter squared. That way we have a final answer in terms of, instead of, so we have the meters squared canceling out, we'll have an answer in newtons. And you should get about 1.3 newtons.